Queria convidar o Nicolas Perrebon, francês, que se transferiu para um território francês, que são as Ilhas Reunião. E o fato de você trabalhar de uma forma insular representa também uma maneira insular de pensar a escassez, porque num lugar desses, a 4.000 quilômetros do lugar mais próximo, cercado de oceano por todo lado, te faz pensar diferente. Então, vamos receber aqui o Nicolas.
Thank you very much, Marcelo. So, thank you. I will start with locating a little Réunion, because I'm not sure everybody knows it. I'm even sure not so many people. Réunion is a small island. It's on the east of Madagascar. And I'm living there and working there with my studio. And I also work in another French island, which is called Mayotte, which is even smaller. So what we can say is like we've got many things in common. We've got the latitude in common, in fact, because we are 21st degrees south, and here we are 23rd. So that's Réunion Island, and it's a real scale there. We've been, I will first present you a project of media library in Saint-Joseph in the south. And the mayor wanted a traditional media library, but it's very young culture there. 350 years ago, there was no human in this island, so it was completely wild. So I started to wonder what's a media library, a traditional media library. So I had to find things, and I found this like an archetype of this traditional, colonial house, and I started to make some a parallel with more think of about the way to enter with the garden, the facade, the workers, and the beyond place is like more family one. And I make a parallel with the project. But it was not the most important point. Maybe it was to have some image. The language of Réunion is very full of images, in fact. And that's the landscape in the south, a very volcanic place. And people, the Creole is the language of Réunion. There was a lot of image, and I wanted even on the building there are some image, some birds, some geometric drawings. So I wanted to start again about an image and make this kind of collage, which were botte de vetiver. It's a piece of a kind of a vegetable which smells very well, which is there, because it's a very rural place. And I wanted to make an image very strong, a first image, and that's the media library. But the funny thing is that some people found other images, and they found it was looking like this one. And that was a success for me, because even it was not the image I chosen, there was an image, and they could get it. So I started to work in intermediary, in between spaces between inside and outside. That's very important in the culture. So I say to the mayor, okay, being traditional is not only to reproduce an archetype, is a way of living. And these in-between spaces were very important. So in fact, we developed all this kind of in-between spaces to say you can close inside and outside. Your way to live is more important than the science of progress, like air conditioning, for example. So we say, we didn't say you have to be sustainable to make a sustainable media library. I say, no, in fact, if you want to really have a traditional one, you have not to cut the inside and the outside. And not to cut it means that you won't have to put a frontier. And air conditioning is putting a frontier. So we decided to make a media library without air conditioning. Okay, we did it. I succeeded to convince the mayor, not because of energy, but because of behavior. But after we have to start to, it had to work, otherwise it will be a terrible example. So the first thing when you make a tropical bioclimatic building is to create an island of a cool island, a cool spot around your building, and the trees do that. So that's the actual landscaping. So we put the landscape inside the building, completely inside. It's totally integrated inside, and that's the first point and the first thing you have to check if you want, especially to make cross ventilation, because if you make cross ventilation with air which is 80 degrees, it doesn't work, of course. So you need shadow, you need soil, you need plants. So that's the first point, to integrate landscape inside and around and inside the building. And after is to avoid, to isolate, to have a lot of insulation, and to have brise soleil, to protect inside from the sun. That's obvious. You can't have any piece of sun going inside. So we draw each orientation differently. The brise soleil are different if they are on the east or on the west, on the north and south. And especially, we have a very special plan of the children section, and each red circle is a kind of brise soleil. So that's the list of all the kind of brise soleil we've got, because each time we have to balance between solar protection and natural sunlight. So we have to make a special one for each orientation. That's maybe a crazy job, but very interesting, because that was like a catalog after for me. It was, of course, the municipality wanted wood, so we make a basis in concrete, and of course we made wood, but taking it away from the soil. It was a way to convince them to make, because we need in our tropical area, we need some facade without inertia. We try not to have inertia. It's like a reverse way of thinking than what you do what they do in Europe, for example. So we did it in wood, and after, the big point was the cross ventilation. For narrow buildings, it's easy, it goes, but for bigger buildings, it's more difficult. So we made a negative depression chimney to take the air away, and that's a part of the drawing. I think this system of cross ventilation to extract it is really something very important to draw my and our buildings. So you see this big space in the middle, and always this outside, that it was just before, after the end of the work, and the trees didn't grow up yet. So now it's going. There are many spaces like that in the Media Library. So I finished with works, and it was really a success. And as Martin told me the other day, French are never happy. And so I say, okay, let's see what's wrong in this building, of course. So I found many things. I won't tell you everything, but I think there was a point about materials. We're living in an island, and it's not so easy to have everything, to have local materials. So I realized that using wood, it was not enough to be sustainable, and realized that also to make tropical bioclimatic projects were not enough to make a complete architecture. So I went gone, and I had a chance to have another project. It was the headquarters of the Architect Council of Réunion and Mayotte in Saint-Denis. Don't be afraid, it's not a project. That's first. That's before the project. They bought a small house like that, and they made a small competition with some architects to make the headquarters. So I arrived there, and I told them, it's not, I won't present you a project, I will present you a process, a behavior. It was very strange not to show a final project. So I told them a story about our island. We import a lot of things. Everything comes by plane, by boat. And we export a lot of garbage. That's the problem. That's maybe our main exportation. It's not very, very interesting. And also, there was something very special because it was for the Architect Council. So we had a network, and it was something we could do together, and he could show what we can do in our world. So putting that all together, say, okay, why don't we reuse materials to build this building? And we present some plans with all we do. I always tell you that I start with the landscape, with the soil, what happens. That's like a basis. Because something's changed. I decided after the media library to put bioclimatic things at the beginning of each project. It was not just an objective to reach. It was like a basis, like gravity, like something we have to do, something we have to start with. And after, we can add all the complexity and the richness of architecture and our cultural environment. So we did this landscape. We put some plans. Of course, we had a bioclimatic strategy. That was obvious. It was pretty easy here. And after, I told them the project can be that or that. I don't know. We'll see what we'll find. And they had a big debate inside, because some part of the people say, okay, it's wonderful, we have to prove things. And other people said, but you're crazy, we don't know, we will sign with him, but we don't know what the building will look like. So, and some people say, okay, it's a council of architects, we have an image, a strong image, and how will you do with that? So finally we won. And we started to look for some materials, a field. That's the most important when you reuse things. So we spent nearly 1 year. We asked to all the architects, if you have got some things in your works, if you destroy a project, call us. So someone was calling, okay, I've got two windows there. Okay, send me a picture. We spent nearly 1 year going all over the island. It seems small, but sometimes we take 3 or 4 hours to go another way. So it's not so easy. That, for example, we took the windows of the kind of hotel of the volcano. We take it, and after we put it in the facade. So we change completely our mind. We don't design, and after we find material, we've got the material, and after we design with material. So the lens and the drawing of this facade is done by the materials we've found. For example, that's steel we found with a rail hand also. We mixed both, and we did it that. So everything was like that. It was a bridge which was going to be done again. We took the platelage, say, the deck. Okay, it was a very beautiful wood with a story. he had really, we haven't got a big story, and to keep this story was very important. And we could just with wonderful carpenters take it again and just cut it a little, but keeping the years, and we put it on the soil. Or for example, you've got here, you see, a glue lamp rayhan. I never used glue lamp for that, but it was, instead of putting it on the rubbish, we took it to make it. So that's all the projects have been like that. And also that was a Douglas stock on the right, because the carpenter bought a workshop, but there was this wood with Douglas, but without traceability. So he couldn't use it in public market because it was he had no papers. In fact, this so we use it, and also we wanted for the bardage. We are looking for some. We did everything like Coke bottles in aluminium. We tried several things. At the end, we say, okay, maybe we can also work with a wood, Iranian wood, which is called cryptomeria, who we can't use. It's a Japanese one. It's very good in Japan, but here it grows too fast, so we can't do anything. So we decide to use this wood, which is completely useless there. So in fact, we added something else. It was not reusing, but it was like a part of the message. And also we use that for the Brise Soleil. There was a small building that we had to break there. So you use it for the pavement. And very funny when we see people who are just making like a mosaic, like that. You see there is a good sign for the project because there is a good energy, and everybody played on that. So at the end, we see the result is a very small one, a very small project, but I can tell you that it took us a lot of time, but it was a way to prove that we can do it on our island. And also, he met many people around the table, people who are starting to work about this reuse issue. And it creates a kind of network with these people. So it was starting something. It helped to start something, a way of thinking. So we'll change of island. That's Mayotte. It's even smaller than the Réunion. That's also a real scale. But it can impress some of you. And that's it was the price before was a small one. This one is much more bigger that we share with Encore Heureux, who are friends. 30 years I was student with one of them, and we decided to go together on this professional high school in Mayotte, which needs a lot of professional high school. So there was a small mountain, a small hill on the site, and we made. I will go pretty fast on the project. That's not the topics. Because I can spend like 4 hours in this project because many things go inside. In fact, it's bigger. The concept was just one theme, one item, one issue. One way we are following. This one is like thousands of roads. So this one we've got a big walkway to protect this hill. And as is a professional construction, professional high school, we wanted to show several ways of building. You can have concrete and ECB. I'll speak about that. A lot of wood also. we wanted just to say two things. There's not a good or bad material, of course, and we can use each one on the good way depending of the program. It's like a small city there, and we also wanted a scale 1 example for the students, as we wanted for them to have every time a scale. And the aim of the project was to develop in Mayotte the ECB, Earth Compressed Brick, the ECB, because it was very famous in the 80s, but after it disappeared. So for two main reasons. The first one is about regulations, because regulations came and it became illegal nearly. And the second one, it was because of an image of progress. That's a very important point when we speak about natural materials. Very often it's like an image very different the people they have when we speak progress. I know the concrete lobby succeeded to put in the mind of the people that the progress is concrete. So sometimes you have to go back and to show that we can do very, very, very interesting things. So we won the competitions, and we started to work and to find the foremost fabrics, workshops of ECB. We work on that to find all the things we could still do. And finally, it's not the topic of this lecture. We succeeded to put new rules, and after there is another association who did that called Arter. It's now legal, and it works, and there is a production of ECB in Mayotte. So it took two years to do that with two people, two architects who came at the beginning of after the competition, 3 years before to start the works. That was very impressive to have this mission. So that's a normal project with a landscape, with sun protection, with ventilation, cross ventilation, but more complicated because here we had all kinds of buildings. So, and we have to think about not only the cross ventilations of each building, we have also to think it in a large scale. If you make a building which prevents the wind behind him, it doesn't work. So we have to think about all that, and every program makes a different drawing, because this is a depressive place that we call it in NECOP, or that's a different way of that's for the classroom with an umbrella roof, different, and we try it on we say in French a soufflerie. It's a wind tunnel. We make this huge model, and it's a wind tool to test. And there are a lot of captors inside, so we improve it. It's 4 meters from 2 meters, the model, and we put it, and we see we can see how if there is wind in each room, and we can also see the movement of the wind to improve it and to change it. So that's a Laboratoire Eiffel. We did that in Paris. So that's this project. It's 20,000 meters, but a lot of wood. Don't worry. Even it's also talking about Earth, and that's the pathway, the walkway around the boot with existing chimney. But this project is also human, and mostly the most important, the thing I will speak about in this lecture is more a human adventure. That's my friend Sébastien. I know him for a very long time, from Encore Heureux. And that workshop we did with all the team. I mean, we were like 40 people working with engineers, with the contractors, the clients, with everybody. We spent there because it was big project. We needed a public. We got environmental rules, and we were going 1 week together, and we were renting a big room, and we were spending 1 week working just on this project together. And the point is, it was the meeting in Mayotte of France, Paris, encore heureux, and Réunion. Co-architects is the name of our studio, and we wanted to create a place here to start working with the people, communicate about the project, and as it was a public project, to share it. And so for that, we needed a place, we needed a school, a house in the to make it easy to see, because it's a big project, and it was waiting for 4 years before the first classroom. Well, more 7 or 8, in fact, because it's Mayotte, it's very complicated. So we wanted to create this house, and well, you know the story. We had in Sada another project, and we had to destroy this building. So it's like we did with the council. We broke it, we took it, we transport it, and we design this house, which is called FAAP. FAAP. It's like a roof. It's a protected roof, but open roof in there. And we started to the works there, and always with students or childs coming, because it's an existing high school, so it was a support, we can say, because the students came here to work, to see how we really build it, and they help us to make also the building. And we mix it with ECB, because that was one of the topics. So the two architects who were there stay working on ECB, and after they made many things. The aim was to communicate about this project also, because very often the project is completely abstract, and suddenly, you open the present, and there is a high school, there is an airport, there is, we don't know, it's completely finished. It's like in between, inside it, in outside. We wanted to change that also in the process, on the way of thinking and sharing the project. So first thing we did, of course, it's a big model, because that's a very important point also to communicate wood project. I think the model is like a perfect way to communicate it, because everybody loves models, in fact, and it's very easy. So we make a big model, and as it was an existing high school, we asked them to buy some press, ECB press, and we teach to the teachers how to do that. Like that, it's very strange, because we were not architects. We were like teachers. We changed, and our aim it was to have a positive attitude on the territory, and that was this place was done. But we also organized some some arts events. That's le balisage. We use it because it was big land. It was to help people to realize what size the high school will have. And it was an occasion for the people to have art, and also some workshops, and even during the works that finally it is starting, we've got some circus shows, for example. So it's an open. Sometimes we open the works, so people can go inside. Children can come. There are big events. And yes, I forgot to tell you, we're building with wood. I didn't forget, and also with ECB. That's a small like newspaper we send like that. We can explain to people what happened, why the workshops are open, how it works, and we see in this image that we use several materials, in fact. And that's, for example, the students' house on the top of the hill. But there are students who made it. We didn't call contractor for that. No, it's a mix between contractors and students, in fact, of course, for question of insurance. So that's it for this huge project. I want to speak you about two other projects and to come back maybe in reunion. Spoke about buildings we've done. We spoke about Lycée des Métiers de Longoni in Mayotte, which is in works and for a long time. And I will speak here about a school competition we've just won. The title of the competition was demolition of the school and reconstructing. It was a title. For political reasons, they wanted because it's a urban project and they need to show that the politics needed to show that they were destroying this project. That's the school. In fact, you can see the existing school. And of course, we decided not to destroy it because, and what we thought and that happened, all the other projects destroyed, and there were wonderful sustainable wood projects, but destroying all that. It was completely, for us, it was completely stupid because, okay, we are doing wood architecture and cross ventilation with chimneys, it was wonderful, I imagine. But destroying that, it was a crime for us, an ecological crime. So we decided to do that with a big risk. We had a big risk to lose it, of course, because it was also political. So we say we will destroy all the red one, in fact, but we kept just this one. Well, this one and this one are very not very interesting. There's nothing. But here, we say we were destroying because we needed here to destroy it because there was some problem of wind. But you'll see, in fact, we built the new building exactly in the same way. So it was just a strategic way, not to say that we are keeping everything. In fact, we will come back after to keeping them. So that was the first point. We had to change the image because there was really reasons. Also, we wanted to understand why they wanted to destroy it. So there were political reasons because they have to show something happens there. So we wanted to make a fragmentation, an horizontal and vertical, horizontal fragmentation and horizontal to change of the edge of this building also. And after, the main thing we did was we planted a forest. Because it was very strange project. Usually with not space enough. Here we had two space. So there is, I wanted to go very fast, but there is like a system because there is a public space and the school is taking all the site when it's open, and when it's closed, it becomes public space. So there is a kind of mutualization of the spaces. But the main thing is to start a project, not speaking about architecture, but speaking about landscape. And so as we had a lot of space, we started to ask what happens, what will happen in our landscape. It's not only putting some trees. How can we live outside? What can the children, what will they do? So we're starting to say, okay, here it will happen here, that it will happen that, and like that you could design outside. With it, we were not speaking, I'd say, hard architecture, but it's very important, especially in our tropical places. That's again, it was a way to say what's happening. So these small sketches just means that there is a huge attention about that. So and after we translate it in architecture, and but it come after. Of course, it's a sustainable project, and there is like a very important technical work to make cross ventilation, because it's not so easy. It was not so easy because the wind was coming here. It's much more easy when you've got a new project, of course. But we take the strategy of a U. I don't know if you know. You make a pressure. The wind is coming on that side, and there is a positive pressure here and a negative pressure around. So it creates a wind into the classroom especially. And I like this section because this section shows many things. It shows that a way of working with wood around concrete, for example. It shows that we are going to do the same work we did with the other. We're using what is existing, but not only the rail hand, because now we are starting a very important work is to make a catalog of everything there is there. So we to reuse it. So it's much more work. I can confess it, but it's very important. We also see cross ventilation. I was speaking to you about it, and with here it was more difficult. So we make some chimneys to help in the restaurant place. And I think we spoke about a lot about it during the workshop. Using wood, adding it to other materials or to other edges is very important also. We have to think about it because it's very light and it can help. Also, it helps to protect, to give more insulation because, of course, all the question of this project is to have the same things about solar protection, about wind, about landscaping, and we can have these items, these issues. And we see we are very lucky because with the income of the project, keeping and guarding the original structure allowed us to have more space. So we could increase the spaces of the classroom doing this varang. Varang is these rooms which are not inside and not outside either, but protected by the sun. So I hope the children will be so happy than in Japan. So, and I want to finish with something else. I told you we're speaking about projects. We've done other with just one, and I will present you something special. It's a project we didn't do already. It's not done. We're just starting to draw it. The first sketches, but it's about a story that happened in Mayotte in December 14th. It happened a big cyclone there. December 14th was a Saturday at 10 o'clock. A cyclone arrived, and it was really a very important one. We don't know because all the instruments get away at 236 kilometers of wind. They get away, but the satellite image are showing that Saint-Denis had more than 320 kilometers of wind. So it was just before Christmas. Sorry, Christmas, And I went there with emergency architects on December 23rd. I went there with the army to help, and that's the landscape I found. You have to imagine that's a rainy, green, tropical forest. It was before. It was like a jungle. It was incredible. And that was living after. It was like a bomb. It was completely crazy. And all the classroom, Mayotte has a situation very complicated. And it has been terrible. There nearly half of the classroom for the children who are destroyed, and 40% of the inhabitations. And Mayotte is a very complicated situation, and there are a lot of favelas, and 100% of them have been destroyed. So we still don't know how many people died at this time. So I arrived there, and I saw a very hard situation, but it was not linked with the way of construct of the materials. I saw bricks buildings who have been destroyed, steel one, concrete one, wood one. In fact, it was not a question of material. It was a question of buildings who were not well done. They broke, even if they were in supposed very strong materials. So that's very important to know, because there is not a fragile material and a strong one. That doesn't exist. If it's not done in a proper way, it breaks. And I saw this image show all these materials. And that's another project, and we can see that a project that was 1 week after. We are on walks on other high school, and we see in this one, nothing happened. Even if it was tall, nothing happened. It didn't move. And you see the other one, it has been destroyed. And that's not the most destroyed project. So now we have to rebuild Mayotte and the premise about the school. You imagine that before the storm, the children were going to the school a part of in the morning and the second part in the afternoon, because there are not classroom enough. And after the storm, there are like 50% classroom less. We have to rebuild them. So we are looking for a way to build fast, but not an emergency, in an emergency way. In an emergency way, in fact, the premise of emergency is that you do things very fast, but they're not supposed to stay, and they stay. So what we want to make to sustainable, and architecture made for a long time also, but we have to do it very fast. So this is what happened in the school. Very often there are small classrooms like that. We don't know, because of question of construction or because of the question of the site, there is 1, 2, 3 classrooms who broke. So what we do, we see that there is some space. So we can use this space, and make foundation. That's a critical point, because we need some concrete. We didn't find another solution for the moment, because there was a very complicated soil in Mayotte, because it's very soft. There is it's earth, and it's very soft, and to build without concrete is complicated for the moment. But that's the starting point, and after we can make a wood project, because after the foundation, we control everything, even the price. So we'll do that with 3 companies: 1 carpenter, 1 electrician, and 1 other. I don't remember. And of course of the concrete company. Okay, with these 3 companies, we'll make this project. And the point is to take the space of one classroom to make, in the first time, 2 rooms, and to keep the first floor for the shadow, and because there are no trees, so you can go in the school. And after, because something very important is also we are completely autonomous, because our electric system is completely off. We can switch it on e-school. So we arrive and we completely autonomous. And after, when we have more time, we can make, for example, some toilets with ECB, but we have to find a way to take water and waste away, or maybe we'll make another classroom. So that's the point of, and the last point of this project. And it's a kind of project who really makes me feel useful in a territory, and I think it's like I know really we can do things in this kind of territory as architects. Obrigado.
Muito obrigado, Nicolas. Acho que deu para ter uma ideia do que é a combinação de precariedade em todos os sentidos, escassez, isolamento, entre outras coisas, o que faz o nosso papel ser mais relevante, principalmente quando a gente fala de pessoas e não de coisas. Então, agora a gente vai ouvir o trabalho do Moore, que vai, enfim, vai nos levar para outras direções.
Thank you, Marcelo. I didn't know what you told them.
I told them that you're becoming bald.
No, we for sure come now a little bit to a more pragmatic side of building with timber. Not that forces us a lot to be pragmatic, but I think today it's part of my role to lead slowly over to Eric, the engineer. Maybe just a few words to myself. I studied in the 80s in Vienna. I got a young father. My wife worked. I took my daughter my whole study to each class, so she knows maybe the same as I about architecture. When the second one came, we changed role and I decided to go back to Vorarlberg. I don't know if you're familiar with Vorarlberg or who was here on Wednesday. Vorarlberg is the most western province of Austria, a very small area, 300,000 people. And back then, in the 80s, it was kind of like the paradise for young architects because there were a lot of work, a lot of money, a lot of young clients. In the urban design departments, there were young people, even politicians. It was a new generation. The craftsmen were second, third, fourth, fifth generation, but also mostly young people, and that was a very fruitful discussion on eye level between all of them, and that brought us all together in a very short time to new heights in contemporary timber architecture. Besides of delicate small single homes, we from the beginning did a lot of competitions. Out of our first 25 competitions, we've won 19 and built all of them. So that meant that we had to grow quite fast. One of these competitions was the Opera House in Bregenz at the lake, one of the largest opera houses in the world, because it also has an opera stage within the lake with 7,000 spectators, and spectators. A classical one is 2,000, and a contemporary opera house with 4,000. So for that little city I'm from, that means that every second inhabitant has its own theatre seat. This is not a timber project, that's why you don't will see it. You might have been seeing it in the James Bond movie Quantum of Solace, where it played the second biggest role after Daniel Craig, a very long scene. And besides that, we did in these first years a lot of timber buildings, not just, as we don't see us as dogmatics, but we like the material a lot and work a lot with it. So a whole bunch of very different buildings, school buildings, sports buildings, offices, hotels, whatever. Like, for example, these are schools there. That's an office building. That's also an office building. One of the adult playgrounds, I call them, within two-story timber structures that are for gathering, for meetings, for playing. Different ceilings that should bring positive impulse to the employees, or fire stations. We did some fire stations in timber, kindergartens, etc. Then we started to spread out. Today we have 8 offices in 5 different countries: Austria, Germany, Switzerland, Serbia, and France. And that's also about the radius that you work in. It has something to do a little bit with my private situation. I'm not very proud of it, but I've got, after that, 4 stepchildren with 2 different wives. So I opened new offices several times in Vienna and Munich and Bregenz. These are our 3 big offices, and the others are actually offices because long-term employees wanted to go back to their home, and so we said we didn't want to lose them. Please open up a Dietrich Unterdriffaler office there, and we'll support you, and we let it grow. That's a system that we like a lot. It works quite well for me. I like it better to have 8 offices, and I know everybody when I come to one of the offices, than to have 150 people within one large space. So that's more or less our team. Last years, it's almost 2/3 are women. And just to show you one of our early works that deal a lot with tradition, with the craftsman tradition in Vorarlberg, but in a very contemporary way. This is a small museum in an old, 400 years old farmhouse in a typical village in the mountains, a listed building where there was a little museum up front, and we were hired to do a museum for Baroque painters from the 17th and the early 18th century, and we did this. We inserted like a house in the barn, and our goal was to hide this more or less. So that's the building, very typical, one of the nicest examples there. And when the museum is closed, you don't see anything about the operation. When it opens up in the morning, it comes out that this is a new place. It's done in silver fir. That's one of the few. We have heard at the last days that you have got hundreds times more species than we have. This is one of our most precious, the silver fir. Wonderful quality of timber. Unfortunately, it's more or less gone in our area now. That's also something that we are not very proud of, that we were part of this exploiting this kind of timber, and it will take a long time to recover. And right now there's just parts in the Black Forest in Germany where that kind of timber grows in larger amounts. And then we did a building, a college, secondary school that was quite important for us and also for the scene in Vorarlberg, because it was one or the first large building in Tilburg, completely in timber. It's a school building that replaced an existing school building, but which was not torn down, but given for €1 to an investor who made an office building out of it, and we built a new school next to it. A very compact building. There was no idea from the client to have this done as a timber building. That was more or less our idea, and we were lucky because the ground was very bad there, so we could avoid deep foundations. We saved almost a year of construction time, so that brought the project in timber to be very interesting for the client. That's it now, 23 years after finishing it. To the right, the school body and connecting library and the sports and building and rehearsal stage for the orchestra to the left. Very simple floor plans, very deep, so the buildings have courtyards to get natural light deep into the building. That's a subject that's very important for us. Without natural light, timber structures and surfaces are not alive. And for the atmosphere in the building, it's really important. But because these two volumes were so compact, the energy consumption is ridiculously just a few kilowatt hours, I think 7 or 8. And we produced 10 times more with PV elements back then on the roof, so it was also one of the first zero positive buildings, which 23 years ago now. Very simple section, sports hall to the left, school to the right. I just want to show, I don't show you the whole building from inside outside, just how a timber building changes throughout the decades. So that was shortly before completion. The library here, also a very different kind of construction of a big building, because CLT was invented just 2 years after we finished that building. So very simple connection. We have built prefabricated cases, elements 4 by 8 meters in dimension. very simple in every kind of sense. So the only luxury thing was, you might mention this small stripe below the large glasses of the windows, so you protect the large part above from the sun, and the stripe below is set back, so you don't need a sun protection, and that allows the students to look out of the window all day long without obstruction, which was in my school career a very important part. There's only one concrete element, the main staircase that is in between the aula, the library, and the classrooms. And then we covered this a glass facade with that perforated copper shield, which brought a very nice natural light inside, but complete sun protection. And at night, that effect turned around. And now, after 23 years, it looks like this. The copper got darker, the wood got gray, but still it can age in dignity. I think that's an important aspect. Then I jump into our largest project. That's the Technical University Munich School of Medicine and Health. A huge operation next to the fantastic listed buildings from the 1972 Olympics in Munich. Very elegant structures, almost immaterial, but with thousands of tons of concrete that are as counterweight for the tension forces underground. And we tried to do something that is, on one hand, very modest compared to these Olympic buildings. Also, we wanted to stay on a very low level within these green listed landscape dams around the 20-hectare plot. And but we wanted to be also a large volume. The Olympic buildings, they have one monofunctional purpose. The one to the right is the football stadium, to the left the swim hall. And we have hundreds, if not thousands, of rooms in that structure. And we wanted to have like the principle that a lot of little fish appear as a big fish. And the structure is linked to the green dam via a bridge. Another image was an air carrier that is anchoring here. It's a very large structure. It's 200 by 160 meters big. It's just two-story, but it houses 14 sports halls, 6 university institutes, library, a restaurant, Audimax, a lot of classrooms, really a lot of rooms. That was the competition model. The difficult thing here was exactly the same thing was here, at least the same amount of sports halls, but they were completely rotten. They were built in Corten steel, 1972 for the Olympics, and even the load-bearing elements were Corten steel, and you could go with your finger through it. They were completely a total collapse. You see here the gym halls, the institutes. To the left we have the restaurant and the library. 6 courtyards in between. You arrive at the upper level, and down here on the lower level there are all the dressing rooms, stuff like that, and 20 hectares of outdoor sport facilities. And one of our images was that, so that's not for the Tezukas done, blue, yellow, red. It shows the different parts. So blue are the sports halls, red is the big canopy that you might have mentioned in the model. And yellow is the so-called rue intérieure, so the main gathering spot, a large distribution zone for students, which is dedicated as a for every purpose. So it's not just walking around without any furniture, but it's a full event room. Also in a almost full timber building, you have a lot of concrete elements. Here we had the problem that this dimension 200 by 160 is for the horizontal forces. For such a low building, quite a challenge. So we decided, together with Konrad Merz, the structural engineer, that we do this rue intérieure mainly in concrete, the auditoriums, and of course all the vertical staircases, and the rest then in timber. The most important element is that canopy. In the competition, a canopy with 28 meter span. We had to reduce that later to 20, but not out of structural reasons, just the budget was just not big enough to allow these 28 meter spans. So this is elements, they are 32 meters long, 4 meters 50 wide and 2 meters high. They sit on that, to the left, on these two pressure steel columns, and are held back with these 7 centimeter tension poles. So a little bit the opposite of the 72 Olympic structures. Here the element itself appears quite strong, but it sits on almost nothing, and just the weight of the ground floor holds it back. So these are the craftsmen within one of these elements, fixing it in Austria at the enterprise, then brought it. That was a transportation, 24 elements, about the size of half of a windmill wing, and they put these into place within, I think, 3.5 days. 4,000 square meters of prefabricated elements with 2 large mobile cranes. You see here the tension poles and the pressure poles, so really more or less nothing. And then when there was a supporting structure for 3 months that you might have seen before here, and that was the first moment that I saw even Konrad Merz, the structural engineer, a little bit nervous before they pulled out the structure, but it did exactly what he intended. It came down 2 centimeters, and it still rests. I mean, that's the advantage in timber, that it doesn't have a long-term, or not such a big long-term, I don't get the word now, but if this would be a concrete canopy over the time, it would come down a little bit. The purpose for this is, it was on one side a sign for this important building, but we also wanted to create a little bit, like in the Formula One, like a box street, because there's a lot of Olympic champions train there, and below the terrace are laboratories, and they put their equipment out and do exercises on all the sports people outside. So it's very convenient because they don't get wet because of that roof. It's a very important part actually in the ongoing processes. So that's shortly before completion. We put in these light stripes because you can imagine 20 meters of canopy, there's not very much light arriving behind. They use it as a terrace for the restaurant for the students. Inside it's very simple. All the sports halls have the same structural principle, these 1.80 meter high glue lamp beams with some skylights, these central air pipes, And then very important aspect from each of these hall, you see in the first floor that rue intérieure. So you're always in direct connection with the people that move around, the other way around. And you always have on one side, in this case to the right, a classroom, to the left, one floor lower, a sports hall, and this very generous indoor street, which is on some parts almost 20 meters wide, too, and completely filled with natural light. That's the dance hall that has also got the timber flooring. The others have a polyurethane floor. The indoor running track. We have an agreement with them that they are only allowed to close these curtains when they have exams. Otherwise, they have to leave them open, not to interrupt these visual connections. This is also a timber space, but these are the two signature colors of the university. So we brought them up in this dark room. We had the chance to design the furniture ourselves, but then decided to do it all in that signature blue and white. The climbing area, library. That's quite funny. That's a lounge, and you see these poles are the former tension poles, or still tension poles, but in Germany you can paint a pressure piece with color for the fire protection, but you are not allowed to paint tension elements. So we took two timber shelves and wrapped them around the steel pole, and the timber now protects the steel element from fire. Another project in France, southern France, in Toulouse, an eco-quartier that's between the city, inner city of Toulouse and the airport and the Airbus industries. Pretty big program, a lot of commercial surfaces on the ground floor. And above it, a park, and to the right, social housing, to the left, private housing, and in the tower, there was a hotel and also a few housing floors. An image from the competition. First we wanted to do the hotel in 3D modules, but they didn't have the ability. It was a carpenter from the Pyrenees, and they couldn't produce these room elements, so we decided at the end to do the whole operation in 2D prefabricated timber elements. So that's it now. So that massive base for the commercials, and on top the up to 11-story floor high building. The little park on the supermarket. We have chosen the color different reds because Toulouse is known as the Rose City because of most of the buildings are done in brick. These are terracotta facade elements. So it's almost itself a little quartier. And terracotta poles for the tower. And then a very important project that maybe works quite well with the topic of the systems. The renovation and extension of a lycée close to Paris for more than 2,000 students. A typical school building from the 70s like that. There are in Paris, I think 700 or 800 and a few thousand in the whole country. Quite poor architecture, very bad energy performance, mostly done in concrete with just maybe 3 centimeters of isolation. That's a little bit the same story as Nicolas said before. We refused to tear down anything, so we left all the buildings existing, which was half of this one, was this one, and the U-shaped school building. So we decided to double the size of the restaurant. We decided to close the school building itself to avoid the dead ends that it had. It had just 3 long, very long, narrow hallways, no place together, no center. Everything was way too tight. And then we decided also that there's this part of the existing school building was 5-story, but the new rules didn't allow a 5th floor anymore. So we wanted to keep this, but whereas we also wanted to create a central courtyard space with, which I show shortly after. The big goal was how to do that without ever having just some of the students moved out. So under full function, within 6 phases, we developed a system that we could avoid temporary buildings, which would have cost millions for nothing. And because we left everything there and just added these timber structures, which are very simple and almost each phase just runs for the summer holidays, and this enabled us to have completely no temporary buildings. These were images from the competition, the new entrance building, the new central exterior courtyard, the new main entrance in the back, the extension of the restaurant as a timber structure. All of that ongoing. In the back you see the city of Paris, the Eiffel Tower. If you look quite closely, you see here to the left that wing that closes the school building, the extension of the restaurant in the foreground. Very simple structure. Unfortunately, the client decided, after we had a battle for years for the budget and were completely in the budget, then decided they wanted to go for a general contractor, and the next day we had 30% more costs for, I would say, not very realistic security in planning and in budget, because these companies try from the first day to make more money out of their contract. So the closed courtyard, very simple structure, very low-key compared to the buildings we have seen before, very simple classrooms. Also the furniture, most of it bought on the market, not produced. And here you see the new forefront, the 5th-story part where we added a row of classes, and inside we teared down 2 floors to get a large central hall for the school to meet together. So that's the vision from the competition. Meanwhile, it's already finished and in function. A school that some of you know, that you have visited in Vorarlberg, the primary school in Höchst. That is for us a very important building because we wanted to prove, because in Europe everything is about compact volumes. And there are so many nice primary schools like from the 50s and 60s where you have a lot of spaces outside, so each classroom has its opposite classroom outside. They can plant, all have the same qualities, which is a lot more difficult in a multi-story building. And we proved that we can be in budget with it and that we can be almost in passive house standard with the budget. That works because normally a school building has around 40% of surface that is just for hallways, staircases, stuff like that. In this building, all the programmed spaces merge into each other, so we just have 3% surface loss from program surfaces. It's a very sprawled area, more or less just one family houses to the north. There's very close Lake Constance. There was enough plot size here, and so we have these 4 groups of 2 classroom units with a central marketplace with their own bedroom, with their own garden, with their own exterior classroom. To the upper right, a sunken sports hall, and to the left, some of the special classes and the administration. Very simple. There was just a 50 centimeter concrete base for the windows and the timber walls. A very important aspect here is that all of the structural parts are the given architecture at the end. So the CLT walls, they are covered here, that they don't destroy them till the end. And these delicate beams stay, of course, visible too. And up there you see the fiber, and the fiber is the bearing structure for the roof. So there is no more timber on the roof. It's the fiber plus the bitumen, the insulation and the bitumen. The only room that is covered are these marketplaces, because here we had all the ducts for the ventilation and the electricity. So to the right, the sports hall, one of the special classrooms. That's when the French visitors always make big eyes that there is material where you can hurt you. They didn't believe it. It's a very simple volume. Another important project that's a Waldorf school, it's a Rudolf Steiner school in Vienna, the oldest in Austria. And there we won a competition for a new building. They wanted to tear down that small one-story typical late 19th century building. And after the competition we said, well, let's try to keep it. The problem was that this building could just hold about 15% of the program. And we looked for a strategy how we could enlarge it by 5 or 6 times without killing it from the appropriate scale. And we left it like till the center wall, so to the left of that thick black wall. These are existing spaces, and the rest is is a new structure with a sunken sports hall. Quite interesting series of classrooms, because I don't know if you're familiar with new schools in Central Europe. They all have, like you've seen before, this cluster system of also few classrooms around a central market place. They didn't want to have it. They didn't want to have connections, and they didn't wanted to have views into the classrooms from the hallway. Then we decided, well, we do the hallway outside, and if we don't have glass there, they don't have natural light. So they had to accept that. And then we connected, we'll see later, all the classrooms with this enfilade of doors, and put the toilets in the center. So always four classrooms have to share the toilets. And the architectural strategy was like to take the given roof, and like, you don't know, somebody know the Eckert family, so we kind of extruded the head of the building, so the rest of the building is more or less roof. So that leftover half building with the material we got here, the timber and the bricks we used for the surface of the courtyard and for benches. We've taken from the excavation of the sports halls the earth produced prefabricated elements for the walls that we fixed on these grass mats. That's when we mounted them, and after that we plastered them with earth 3 more centimeters, and that's a perfect solution for the air conditions in the building, because it takes a lot and gives back a lot of humidity. So from above, you see that big head. The whole glass body is shown as part of the roof. This is one of the hallways with the windows, which also works as outdoor teaching. At the end, you can go down to the courtyard. This is this series of connections between the classrooms. And the toilets, they have 10 doors in a space of 15 square meters. I don't know if the kids know always their way around, but... And what is funny, that when we got the commission, I don't know if you're familiar with Waldorf schools, but they mostly have these weird shapes of wrong understood ancient language of Rudolf Steiner. And with keeping this roof, there's a lot of spaces now in there that look perfectly like Rudolf Steiner spaces without having the idea to do it. So the very extreme room proportions. Here you see the finished earth surfaces, a terrace cut in the roof, and the sunken sports hall. This I just shortly present you. It's a lycée on the same island as Nicolas mentioned this project before, and he explained a lot about it, so I just show it quickly. Very difficult site, because there are tsunami danger and landslide danger, so from both sides, and it's very close to one of these favelas on the island. We kept more or less all the existing trees on the site. The site began 2 months before the cyclone. Now all the trees are gone, so not one of them that we kept is anymore there. And we have about the same principles about structure, the BTC bricks. What we use to here is bamboo, not as a load-bearing thing, but as a sunscreen for the outer hallways. So also a place to meet. You see the bricks on the left, bamboo poles to the right, which are double layered to prevent the sun. And did some tests. Taka said last time, bamboo is nothing that lasts. We know that too. This bamboo will not age, but maybe it's also something that not me have to carry around these poles, but maybe some of the students or some of the natives can have work replacing, like maybe every 5 years, these elements. It's besides the pressed earth, that's more or less the only exploitable plant on the island. Another important project, that's a holiday village in Switzerland for low-income families in Appenzell, a mountainous region. That was interesting for us because they commissioned us directly together with Roland Neiger, and they let us complete freedom where to put that holiday village. They showed us all these fantastic plots up on the mountains with gorgeous views, and we said, no, you have to place that directly in the village because you want to make a living out of these 300 guests. You have to have your restaurants closed. You have to have the station close. So we decided us for an industrial plant, a plot that was then, with the votes of the inhabitants, was changed into tourism land. We had the luck that Bluma Lehmann has a plant right in the next village, but each piece of timber that it used is from that little village. So we enforced the forest owner to make lists what they can provide, which kind of wood, which dimensions, and then that was really a lot of work together with Bluma Lehmann. We checked out what can we use for what. So that's the finished thing. It's almost like an image story, because to the right in the back here of the station, to the left, the center of the village, there is a river going around that village, and the train also. So the photographer stands on the train tracks, and there is not much in common with the historic buildings. The only two things we kept is these rows of windows that are very typical, and the low room height. As we wanted to come up with 1.80 meter high spaces. These farmhouses are sometimes just 1.60 meter high. We ended up with 2.10 meter, which is still low, but gives the guests an impression how living in the countryside is or used to be. So protect the courtyards for the incredibly many kids that always are there. Integrated terraces, very simple apartments. The only precious thing are the views to the outside. 4 common houses for the elder people, for the kids to swim, and for some animals. I'll finish with this now. We are challenging time where I think that the numbers that we are used to take into account for new timber buildings, or even for buildings, will change into a complete CO2 measurement. And these office houses we do for the owners of Lego, the play company, who want to have the Danish they have a limit of 8 kilograms CO2 per square meter. They wanted to do their Danish numbers here in Switzerland. And so we designed to a very early stage that the complete project, even before we give it into the authorities, it was completely detailed. This central part is in concrete, and the office wings are 100% timber. And we found out some very interesting things about the CO2 footprint, because so we checked different kinds of structural elements, how many kilos they use. So for example, a hybrid system and a 100% timber structure just has about half a kilo difference, and a 100% concrete structure has about the kilo 20 difference. So if you take into account in total it's 8 kilos, you see that you have completely other problems too that you have to take care of, not just the main structural material. So we did all these lists. What are the advantages, disadvantages? And the result was we do it like this now, 100% timber here. That concrete, I always call it the concrete flour, which is not that bad, because here we said we just do the concrete floors. There's no additional layer. And compared to the timber floors with a lot of additional layers, the footprint is not much worse, actually. So this is under construction now. And just to finish, some social housing. We do a lot of social housing, also in timber. So this one with an 11-story tower. Here we have the strategy that we do the floors in very thin concrete prefabricated elements, 3 by 3 meters. Then we have thick timber columns and a timber facade. This is price-wise actually very good, because of course for social housing the price is a topic. Even that quite differentiated, complicated geometry works. That's the model 1-to-1. A mobile kindergarten that is completely done in prefabricated 3D modules. You erect it within 2 days. You could take it any day apart and put it up somewhere else. 3 elements is always 1 classroom. So very cheap and practical solution for temporary buildings, whereas mostly they last forever. Nobody takes them away. So everything already installed, all the pipes and gains. And then just quickly I pull through a housing system with 12 by 12 big units that can work 2-story up to 4-story, and also in a closed plot within cities. A project where the Secretario yesterday said something about all the waste we put into landfill. Here we use 12,000 pairs of skis that were thrown away as rails for the apartments, because of course there are a lot of products you can reuse or kind of giving them a new meaning. These skis they will never rot, and they are completely weather and waterproofed. So why should you put them away? And these 12,000 pairs you have each year as a garbage out of the rental ski market. Very simple floor plans. What we do more and more for the circular economy, we do these lists of elements that we produce, that we assemble the buildings with these elements, and we can completely dismantle them if so necessary and build something completely different out of it. Yeah, what's the future of building with timber? It's late, maybe it's too late, but still the forest is growing. It's still there. It's growing. If it goes good, we'll have a lot of timber buildings that educate us and our children, store a lot of CO2. So maybe we still have a chance, and hopefully stupid assholes like Trump or Bolsonaro or complete dumb megalomaniacs like Musk or Dr. No, if to come back to James Bond, will not take everything over. Thank you.
It's going late.
You have my presentation loaded?
Yeah, but let's see where. Oh, I downloaded it, right? See if it's one of these. What's the name of the presentation? Not this one.
It's Núcleo de Madera, and then my name at the end, I think. You want to copy it again?
No, I have it here. Just PPTX, Núcleo de Madeira. Just trying to, because I put them all
Maybe I have the-
together. No,
maybe
I put
I have the date first.
the date first. Yeah, maybe.
We do it back now or?
No, last one. Com licença, nós ainda temos uma última apresentação, depois um pequeno espaço, um tempo de perguntas, e depois a gente vai ter um encerramento e um café lá fora. Okay. Stop now. I don't think it's a good idea because they are going to... Núcleo da Madeira. Ele não vai falar. Ele não veio. Então nós substituímos. Wow, it should be here. Núcleo Pereibone, Wood Construction Global Meeting, Martin Hurtado.
Maybe it's just easier to copy it again.
It's amazing because I knew we had it. Okay. Yeah, okay. Oh no, it's in here. I forgot it. That's right. That's right.
So, but copy it on the computer because I've
Yeah.
had trouble.
Yeah.
Sometimes I lose the pictures if I leave it on the disk.
That's what we're going to do. Because I can't see your... see, it's not connected. It's not showing up. Why?
pack?
No. Okay, now, because this is see, cash,
Here, it's
the first one.
the first one.
Okay. Do you want this?
Sure.
Okay.
And I'll use the microphone as well.
Muito bom. Então, a gente vai para a última apresentação. O Eric. O Eric é o único engenheiro desse grupo. E como engenheiro, ele trouxe um outro tipo de expertise, né? Uma visão que abarca todo o processo, principalmente a variedade de projetos que ele trabalha, porque ele trabalha para vários arquitetos diferentes. E é nesse aspecto que eu acho que a gente pode mais aproveitar o trabalho dele. Com vocês, então, Eric Carr.
Thank you, Marcelo. Good afternoon, everyone. Thank you for sticking around. I'm sure you're all tired. I cannot be as exciting as Marcelo yesterday, but I'm going to try not to put you to sleep. I am from Quebec originally and started my career designing in concrete and steel in Ottawa. I never took a timber course. So for those who are thinking about designing in timber but haven't done so yet, it's never too late. And I consider myself now to be a very spoiled timber engineer because I come from a country of only 40 million people, but we produce 47 million cubic meters of wood every year. We only use 30% of that at home. Also, I live now in British Columbia, where there is a very strong native culture. So there is a history of timber architecture that goes back centuries where I live, and there are still many, many native bands that build buildings out of wood. And my first project in wood actually was a First Nations school in 1995. And also from a regulation standpoint, closer. Yeah, from a regulation standpoint, Canada is quite open. The only place that I can think of that might be better than Canada from a regulation point of view is maybe Austria, where Much comes from, or Switzerland. The responsibility for innovation or for doing anything that is outside of the code is with the engineer. So we have a lot of freedom, but on the other hand, we also have a lot of responsibility. So we founded Equilibrium in Vancouver in 1998. And then more recently in Paris and Atlanta about 3 years ago. We are about 25 people in total in 3 offices, so we're a very small firm, I would say, but we do all kinds of projects, and about 90% of them are in wood. But we also design the concrete and the steel that is in our structures ourselves. And for those who come from France, we work both as engineers of record and as specialty engineers, so working for suppliers. And we always prefer to do both on our projects. So we do First Nations projects, as I said. We've done over 100 of those. We do schools, we do university buildings, airports, small projects like this yoga pavilion on the right-hand side, which I will talk about a little bit, sports facilities, multi-residential office, and so on. In 1998, when we started the firm, timber technology in North America was very, I would call it very primitive. It was, steel plates, bolts. There were 300 CNC machines in Switzerland at the time, but none in Canada. We got our first CNC machine in Canada in 2001, which completely changed how we design structure because it shifts the economy of labor and materials because the CNCs, of course, can work very fast and do very, very complex cuts, but also do them very accurately. So This opened the door to using more sophisticated connection systems. And we very quickly tried to combine the best of European technology with North American technology. And this is an example of a connector that actually came from Germany that we use in this project, where we acted as specialty engineers. This is the Raleigh-Durham Airport. Originally the project was designed with glued-in rods, which is a relatively difficult connection system to use, and then we replaced it with this other one, the Birches system, and saved $1.5 million on the timber package. CNC technology also allowed us to do very complex structures. This is the Art Gallery of Ontario in Toronto, which was designed by Frank Gehry. And if you look closely at this facade, you will see that the timber elements are at a slightly different angle. They fan from left to right. So every single connection in this structure is geometrically slightly different. So we use CNC manufacturing to keep the steel connectors the same, but to vary the geometry of the wood, to unify the connection systems as much as possible and bring the project on budget. And I love to show this picture here where people go to an art gallery and look at the structure instead of looking at the artwork. In 2007, we were invited by a group of Austrian investors who wanted to build the Austria House in Whistler for the Whistler Olympics. And we discovered the passive house concept there, but also CLT, which we didn't know about before that. So we came back very excited about this new construction method and convinced an architect who wanted to build his own custom home to build it in CLT. It ended up being the first CLT project in North America in 2000. We designed it in 2007, but it was built in 2009. And this house actually was delivered from Austria by KLH in containers. And the entire timber structure was built in only 5 days. So there's a view of the house here, and then there's a view of the completed project. But every project in Canada at that time could not be built with CLT from Austria, so we looked for other panel materials, other panel products to do some other mass timber projects. This is a renovation. It is the North Vancouver Civic Center where I live. So on the left-hand side, you have the original, on the left-hand side for you as well, the original Civic Center. On the right-hand side, the original library. They built a new library, and then they connected the two buildings together to make a larger city hall. And the connection between the two buildings was a tube that was built from glulam and mass timber panels. These mass timber panels were made of what we call timber strand. So it's a little bit like OSB, but it's very thick, 9 centimeters thick, and it's made of panels that are 8 feet by 64 feet long. So we have 4 layers of this material, basically building a custom-made hollow CLT panel, which was prefabricated in the factory, connected together with screws, and then shipped to site in 12-foot wide panels by 32-foot long panels. So let me see, to 4 meters by 10-meter panels. Now this material is quite industrial looking, but when you sand it and you build it at a very large scale, it actually has a very nice appearance, a very nice texture. And you see here that connecting central space from the inside with the glulam columns and the prefabricated panel on the roof. The architect, Michael Green, also used the same material, but in a much thinner format as a ceiling in the original concrete building, in the original library. And the black timber that you see here on the guardrail was actually made from a tree that was in the central space that we had to remove to build the connector. So the wood was all milled and used in the finishing of the guardrail. This project, you may have seen, was a very pivotal project for us from a technology development point of view. This is in 2009. We're at a time where the BC government was investing significantly to help develop the use of timber in the country. And this university project, the Earth Sciences, was chosen as a demonstration project to show that timber technology basically had become a high-tech technology and that timber could be used in almost any project. Now, university buildings typically have a very high level of expectation in terms of performance. They're typically built out of concrete. So it was our mandate here to prove that we could build a timber building that performed as well or better as a concrete building. So again, we couldn't get CLT quite yet, although two suppliers in Canada were getting ready to produce it. We knew that we wouldn't get the CLT in time to build the floors. So again, we used the same timber strand or OSB-like material for the floor panels, but because they're only limited to 9 centimeters, we had to make them composite with the concrete. So you see here a typical floor panel with the timber, 2.5 centimeters of acoustic separation, and then a 10 centimeter concrete topping for a structure that spans 6.4 meters. We also had, it's a 5-story building. We also had some lecture halls that we had to transfer over, and the architect required that the entire central portion of the truss remain completely open, as well as the corridor on either side of the column. So we have a kind of a mix between a diagonalized truss and a Virendale truss, transferring 4 stories of construction over a 21-meter span. So the solution was to use a steel concrete composite bottom chord, mainly because the diagonal doesn't actually meet the column. So to take the shear there, we had to go steel, but the top chord is made up of glulam concrete composite, and then you just have a steel diagonal. And that 21-meter truss, when the scaffolding was removed, only moved 10 millimeters or 1 centimeter. We like to keep our connection details simple. You can imagine this is a very, very high load that is coming out of this diagonal, but timber is very, very strong in compression parallel to grain. So you bring the load from the diagonal directly into the end grain of the column and the top chord to achieve a very efficient connection. The CLT was produced just in time to deliver the roof panels. So what you see here are the first CLT panels produced in Canada, I think. There were a handful of panels that were produced before that for testing, but these are the first commercially sold panels, which we chose to cover with a membrane in this case because we get a lot of rain in Vancouver. And there were other innovative elements in this project. This is the canopy, which was also built out of CLT. But the most innovative or technologically challenging element in the project was what we call the flying stair. It's a cantilevered stair, which is only attached to the floors. It is not suspended from the roof. It is not connected to the side column there. It's completely cantilevered. It's very easy to do in steel and concrete, but as far as I know, had never been done in wood. So again, we worked with a European connection system called the HSK system. It's essentially a perforated steel plate which is glued into the wood, creating a very rigid connection. You see here the landing of the stair, which was glued into the wood panel in the shop and is being flown into place to be connected with the stair runs. And then you see the holes here where the glue is going to be injected on site to complete the connection. So there's a view of our completed structure. 5 stories tall. I honestly didn't think that people would use this stair. I thought they would be scared to use it. But if you stand at the top of the stair looking down at this timber stair, it was quite frankly scary. But I asked some students what they thought of this stair, and none of them seemed to be concerned about it at all. So there's a view of the stair with all the finishes. You see a line of sprinklers, lighting, and of course the glass guardrails and the floor finishes. So this was one example of a project that was chosen for demonstration and technical innovation, but we did a few of those at the time. So this brought us to the point where we thought we could be looking at building larger or even taller wood buildings. And again, with Michael Green, we got a small grant to do a feasibility study called The Case for Tall Wood, and you might have seen his TED Talk where he talks about the report. We started with the idea that we would do a concept for a 12-story building, but then Michael went to Japan and he saw the Japanese temple that is about the same height, but almost 1,000 years old. So he came back and he said, well, they did it in Japan 1,000 years ago. So we're just going to have to go taller. Now, this is the architect, right? The architect doesn't mind going taller because the engineer is going to figure it out, and that was my job. We decided to go 20 stories. So we developed the concept and we analyzed it, and it was actually working quite well. So I told Michael, you know, this is working really, really well. Don't tell anybody, but I think we can go taller. We can go 30 stories. So he goes to a conference in Australia, and he tells a Canadian journalist that we can go 30 stories. And the next day, in the papers, there was an announcement that Michael Green was building a 30-story tower made out of wood. So the report all of a sudden became 30 stories, and it was published that way. And it then supported, the government then decided to build a demonstration building, not 30 stories, only 8 stories in Prince George, a small town in British Columbia. And this was actually, it received a site-specific approval because we were completely outside of the Canadian code at the time, both in terms of height, but also because we were exposing absolutely all the wood, including the stair, which you will see later, which is made out of wood. And because we were planning to expose absolutely everything, we needed a pretty sophisticated strategy to hide all the services. So what you see here is a cross-section of a typical floor, which allows us to hide the plumbing underneath and some of the electrical wiring on the top. There's a 3D view of the concept here. And then in the field, essentially it's a 5-ply CLT panel with a 3-ply CLT panel, and they're connected together structurally to create a corrugated floor structure. This was also the first project in North America to be built with a wood core. And at the time that the building was completed, it was the tallest modern timber building in the world because we didn't have a concrete podium. We started with the wood directly from the ground up, and the building was 30 meters tall. So it was the tallest at the time, aside from the temples in Japan, of course. So there's a view of the building entrance using different materials from the area, different engineered wood products, CLT, Douglas fir glulam, LVL, and so on. And this is a picture that you probably saw, a little bit of an iconic picture of the top floor before the finishes were installed. So these two projects, the two university projects that I showed, led to other university projects. This one was the first and the largest mass timber project in the eastern coast of New England, of the US. It's in Boston. It's the University of Massachusetts. And again, we decided to build the entire lateral system out of wood. It's a mixture of CLT shear walls and timber braces. Now, we're not in a very high seismic zone, unlike the other two projects, but we're in the United States where getting code approvals is a little more difficult. So we had to work quite hard to convince the authorities having jurisdiction in the area to let us build the entire lateral system out of timber. So there's a view of our bracing system, and the building, which is C-shaped, has a courtyard in the middle. It's an atrium, which has an accessible roof, which is planted, so very heavy soil loads, very heavy snow loads. So you see here the transfer truss, which supports the planted roof, and then a view of that roof structure from the inside mezzanine, which is a hybrid steel and timber truss, 3D truss structure. So you see here some of the connection detailing for that truss. And a view of the accessible roof with the transfer truss in the background through the windows. And here's a view of one of the laboratories, computer laboratory, I think. This is the integrated design building at UMass. That led to another university building, this one in a high seismic zone in Oregon. And there are a number of innovative elements in this one again. So this one, first of all, required much longer spans with a very limited building height. So we had to find a way to go very long distances with a very shallow structure. So we came up with the idea of doing glulam beams with concrete composite, but to turn the beams on the flat. So essentially what we're creating is a very wide wood concrete composite beam going 12 meters and with a depth of only 65 centimeters. And the beam is actually continuous over a double span, which helped us keep it quite shallow. So the wood concrete composite in this case was achieved using diagonal screws at 30 degrees. What you see here is the situation of the column. So in that zone, the concrete is actually in tension and the beam is carrying negative moments. Over the main atrium, we also have a 10-meter span, but this time we're doing CLT concrete composite with 24-centimeter CLT panel. So again, a very thin structural system for those kinds of spans. So what you see here are the screws, again, at 30 degrees with an acoustic acoustic layer. And because we were really pushing the limit in terms of span to depth, we did some finite element vibration analysis, and then we had the opportunity to go on site and actually measure the vibration of that floor. And we found that the correlation actually was very good. But the most innovative element in this building is the lateral system. So this is the School of Forestry. The university was very much interested in demonstrating timber innovation. We're in a very high seismic zone. So we gave them actually three choices. We told them we could do regular CLT shear walls. The problem is that in those days in the United States, the design requirements for standard CLT shear walls were really penalizing. The forces would have been way too high. We proposed what we call buckling resisting braces, which is a very ductile steel system used in Canada and the US and probably in Europe as well. A very efficient, very ductile system, but steel-based. And then finally, we gave them a third option, which was a post-tension, self-centering CLT shear wall system, which you see here. So the idea is to run steel rods through the middle of the wall, and then when the wall is installed, to post-tension the rods, so creating a rubber band, basically, So when there's an earthquake and the wall moves back and forth, it always comes back to the middle. This is what we call a low damage system. So we control the drift really, really well, also by absorbing energy, and I will show you how we do that in the next slide. But also because the walls always come back to the middle, when the earthquake is over, you have a building that is straight and usable. So this is the future of seismic design for resilient buildings. Most of the codes right now don't include that kind of approach, but when you think about ensuring that buildings last a long time, you have to start thinking along those lines. So here's a situation where you have two walls side by side, and there is an energy absorption connector, a U-shaped steel plate that absorbs energy in an earthquake. And then at the bottom here, you see a single panel wall with the same kind of system at the end. So here's a view of the finished building, that 10-meter CLT concrete composite floor above the main lobby. And then there's a view of the main lobby with that wood concrete composite floor above. And you will notice that the CLT panels are spaced 15 centimeters to incorporate sprinklers and lighting, which is a strategy that we use a lot. This is a fun little project. When I was a kid, I used to build model airplanes out of balsa wood. We had a little project for an owner who does maintenance, aircraft maintenance, and he wanted the building to look a little bit like an airfoil. Now, wooden airplanes were built with very, very thin timber elements, very closely spaced, and then braced together to keep them from buckling, but using very, very thin elements that are all connected together into a strong airfoil. So I proposed building the roof structure using CLT panels, only 10 centimeters thick. So we cut a rigid moment frame out of 10 centimeter CLT panels and connected the elements again using that perforated steel plate, which is glued into place. And you see here that roof structure with the sprinklers and lighting again incorporated into the structure. And there's a view of the building from the outside. Another small but interesting project. The foundations for this building was retained. So we built a very light pavilion on top of an existing basement foundation. This building is built entirely out of light frame. But because of the geometry, which is quite complex, we decided to build a template using the CNC equipment. So the CNC equipment can get very accurate geometry with a template, and then we install the elements onto this template to get the correct geometry. So this way, each petal of the temple is built from 4 panels that are built from 4 different templates, as you see here. And then 2 of the 4 panels are connected together in the factory and then shipped to site and supported on glulam arches to achieve the geometry of the yoga temple. So there are some images. The building is actually 4 stories tall. It's not that small. And there's a view of the yoga temple with the ancillary building on the lakeside, again in British Columbia. Another project that we did in a remote area. This is a small village, quite far north in the province, that they had an arena. They had a hockey rink that had roof leaks, and the structure, which was originally built out of wood also, had completely rotted, and we were forced to close the building, which was quite devastating for the village because there's not a lot to do in the middle of winter over there. So losing their hockey rink was a really difficult thing for them, and they were quite angry. But when they saw the new building a few years later, They were very, very proud of the building and very grateful that we were able to build it out of wood. So this is a glulam arch, truss arch with light frame prefabricated panels. So very simple, very economical structure in an area that actually gets quite a bit of snow. So this is a more recent project. The building actually opened about a year ago, officially less than that, 6 months ago. This was the first office building that Google built out of timber. It is a 5-story mass timber structure with about 17,000 square meters. There are 2 major zones in the building. On the left-hand side, you have all the support spaces, including boardrooms, washrooms, cafeterias, and so on. On the right-hand side, you have the main workspaces. There is roughly 1,000 employees working in this building, so these are large floor spaces. And then an atrium in the middle joining the 2 structures together. The structure on the left is a very traditional glulam post and beam with CLT panels. The one on the right, because we have a lot more headroom, we were able to do a much more efficient system. So we have, again, the post and beam. We have purlins this time, and then a much thinner CLT panels with only about 18 centimeters of timber per square meter. So it's quite efficient for a 10 meter by 10 meter grid. So there's a view of the building from the outside with the double height space on the right-hand side, the 5-story space on the left-hand side. And here's a view of our typical floor plate. And what you see here is the mass timber floor, which is, well, it's entirely mass timber for the gravity system. But for the lateral system, and we're in one of the highest seismic zones in the world here in California, we have, again, a steel structure which is accepted in the code. We wanted to do a combination of steel and wood, as I will show you in a minute, but we just didn't have time to do the testing required to have that approved. The connection details are very simple and completely free of steel. So you see here the purlins, which are elevated above the girders by 30 centimeters to allow mechanical services to run through. And there's a notch in the purlin and then some screws for reinforcing. But otherwise, the entire connection is done only with screws, which is also very fast to install. The main girder to column connection is a similar approach. We make a big notch in the column, we slide the beam into it, again connect with screws, and this detail also allows us to make the beams double span, which makes it possible to have a shallower beam. And as you see, the upper column bears directly on end grain on the lower column to avoid any shrinkage between the floors. So this is our exploration of the various lateral systems. We were hoping to use a steel brace system, which is in the code, but using timber beams and columns. But this system would not have been approved in California without significant testing. So then we thought, okay, we're going to do the lateral system entirely out of steel because it has to comply with the code. The problem with that is that if your lateral system also carries gravity loads, you have to fire protect it. And Google was hoping to leave all the braces exposed, as they normally do in their buildings. So we then went to the third option, which was to have a wood gravity system, which is, of course, fire resistant, and then to have a lateral system which is completely independent from the gravity system and can then be left completely exposed without fireproofing. The timber actually came from Canada and was installed by a Canadian company. The general contractor was from the US. You see here the floor, the timber floor gravity system, and the lateral braces, which are again completely separate from one another, as you can see here. There's a view of the atrium, which is open over 4 floors. And at the front of the building, we have 4-meter cantilevers, up to 4-meter cantilever balconies, which were achieved, forgot to mention that, which were achieved using wood concrete composite. Again, you see the connectors at the front of the building for the cantilever. The entrance also has a couple of missing columns. So we have 4 stories of structure being supported on a 6-meter cantilever. The total cantilever is 7.6 meters to the edge of the floor. And here's a view of our main entrance with a completed building. So there's a view, sorry, you can go ahead. I'll give you the images later. Michael Green, again, we work a lot with Michael Green. These are connection detail, our steel-free connection details. So you have the purlin to beam connections and also the girder to column connections. And again, the mechanical systems run over the girders, the sprinklers, and then the bigger mechanical systems run under the removable ceiling. There's a view of our atrium stairs, which are made out of steel, very long span stairs, because they're double height. And then some of the workspaces throughout the building where people can go and work or have lunch. And then a view again of our entrance. Now, I've shown a lot of relatively complex buildings. I think we have shown by now that we can build almost anything with the timber technologies that we have. So the next step is really to try to scale the use of wood up so that we use a lot more wood and replace a lot of the concrete that we currently use. So every building cannot be a demonstration building, of course. We have to develop structural strategies and systems that are very cost-effective, fast to install, and resilient and reusable. This one is a 14-story structure, 11 stories of timber on top of 3 stories of concrete. It's a multi-residential project in Madison, Wisconsin, which you see here. And the approach that we took here was, on the basis that most of the timber volume is in the floor deck. We decided to do a very thin steel post and beam, which is going to be completely hidden inside the walls, and then to expose the timber as much as possible. So about 80% of the structure is in the CLT, 20% is in the post and beam. And so this way we reach the compromise with the cost, but also with fire regulations where the authorities were more concerned about the fireproofing of the columns than they were about the fireproofing of the floors. So there's a view of the building during construction, and then a view as the structure is getting completed. I think many other people said this, we have to reuse more of our buildings. This is a 7-story concrete building in Washington, D.C. It's the first vertical expansion using mass timber in the United States. So again, we're adding 3 stories of mass timber on a 7-story concrete structure. And we were, in this case, specialty engineers. We only designed the timber. But with this approach, the client was able to add 3 floors with very minimal reinforcing of the existing concrete structures. There's a view of the remodeled entrance. And then one of my last projects, this one in Paris. This is the first project that we did in France. We won a competition with Cause and Dream. This is the Rectorat de Créteil, so it's an office building for a regional school board. 9 stories of mass timber with 1.5 floors of concrete. The building is basically a building that wraps around an interior courtyard. Now, my thinking here was that the economics of mass timber in France are different than the economics of mass timber in North America. In North America, first of all, we now have quite a few CLT suppliers, and CLT is about half the price of glue laminated timber. In France, it's not quite the reverse, but CLT is comparatively more expensive than it is in North America. So the approach was to use very closely spaced purlins at 1.35 meters, and then to use the thinnest possible wood deck that we could use. So we ended up with a 2.7 centimeter 3-ply CLT. It's a product that comes from Austria, typically called Dreischichtplatte. That was the approach. And this was the sketch that I did by hand. I'm a dinosaur, so I still draw everything by hand. So the idea was, again, similar to Google, to have deeper beams on the outside of the building, and then in the corridor, where the span is smaller, to have shorter beams and to elevate the beams above the girders to allow us to bring all the services through the corridor and then into the office spaces to the side. The final detail actually ended up being exactly the same. The only difference being that the supplier replaced the Dreischichtplatte, which was an imported material, with 5 centimeter concrete panels, and to save some money. So this is our corridor with the shallower beams where all the, it's the services highway, where all the services come down and then branch to the left and to the right into the office spaces. And we also pre-cut some openings in the beams in the factory. We made all the cuts the same to allow for some of the services to also travel within the office spaces where required. And of course, those cuts are reinforced with screws. At the terraces, there are quite a lot of terraces at one corner of the building. We had to reduce the spacing of the beams in half. Because we go from the inside to the outside, we have to step down quite a bit. But we had to keep the same elevation at the underside of the beam. We had to go to a wood concrete composite solution. So the majority of the structure is just regular post and beam with a deck. At the terraces, we had to go wood concrete composite to keep the same underside of beam elevation. So here you see the composite system that the supplier chose. It's a big steel dowel that they were all installed in the shop. There's a view of the terraces during construction, and a view of some of the spaces again once the structure was completed and everything was cleaned out. So a few stages during construction, just the structure and then some of the facade going on. The project is actually still under construction. It will be completed in a few months, 2 or 3 months. So there's a view of some of the facade finishes, a combination of wood and metal. And then in the interior courtyard, a wood facade everywhere. So I'm going to wrap up with some comments about the future of wood in construction. In 125 years ago, we used 20% mineral materials in construction and 80% bio-based materials. In 1950, we went to half and half, and now we're only using about 15% bio-based materials in our construction. And be able to be net zero by 2050, as the plan seems to be, we're going to have to go from 15% to 60% bio-based material, which is, in my view, an incredibly difficult task. Now, we're making progress, but I think the progress that we have to make has to be not so incremental, but really in massive steps. And as we were discussing things amongst ourselves over the last week, I came to a number of conclusions. When I was in the Forum Bois in Paris a couple of weeks ago, Andrew Waugh made a comment that I thought was very important. He said, we have to remember why we're doing this. Why are we promoting the use of wood? And the answer is very simply that if we don't, we're facing a catastrophic climate situation. So when we think of risk, and engineers are very risk averse, and architects are equally risk averse, we think of the risk of damages to walls, or the risk of vibration, or the risk of things which in the end don't compare at all to the risk that we face with the degradation of the climate. So I think there has to be a reset in our understanding of risk and in our decision-making process when we think of building codes. I believe our building codes have to consider the impact that we have on climate, and every engineering association around the world says that as engineers, we have a responsibility to design sustainable structures, but that also begins with the codes. If we could relax the requirements that we have in our codes to save even 5% of the materials that we use in our structures, we're making a massive difference. And this would not necessarily compromise the safety of buildings. It would mean that maybe the floors are not as stiff as we're used to. It would mean that maybe once in a while a partition develops a crack. But when you consider that risk against the alternative, I think this is an easy decision. So we have to start thinking, we have to start making decisions with that in mind. We also have to find ways to scale up all the innovation that we've been able to achieve so far and use wood in many, many more structures, not just a few incremental improvements from year to year. So this is the last project. It's a very, very small project. And I'm using this project to illustrate the fact that we are, in fact, making progress with codes. This building is mostly built out of wood, not entirely. You'll see why in a minute. But in Vancouver, this project would not have been allowed even 5 years ago. We were able to get an approval. It's a school. It's a cultural center as well as a school. So it's a public building where there can be assembly. It's 4 stories. And the main structure is glulam, post and beam, and CLT. But because the building is right next to an existing building, we had to build a firewall, and the firewall had to be a non-combustible material. So we have concrete for the foundations, we have timber for the main structure, and now, because we're building against an existing wall, we cannot pour concrete, we have to introduce masonry. And then we had a little bit of steel over the theater because we didn't have enough height. So we have, in this tiny little project, 4 materials, which made the construction extremely difficult. And it rains all the time in the winter in Vancouver. So this was a very inefficient building in the end. Now, if we were to permit this building again, we would be allowed to use CLT firewalls, which would simplify the construction of the building a lot. So, that's repeating this picture. So we're making progress code-wise. There's a lot of progress happening in the US as well. But we have to keep the momentum of innovation. We have to speed up how quickly we increase the amount of wood that we use in buildings if we want to meet that target of 60% in 2050. Obrigado.
Thank you, Eric. Thank you for the excellence of your work. Oh, acho que eu vou falar em português mesmo. Are you going to wear your stuff, or will I have to speak in what? Greek? Bom, nós estamos chegando ao fim da nossa jornada. E eu queria começar dizendo que ela foi uma jornada coletiva. Ela não é uma jornada de um indivíduo que teve uma ideia só, mas ela é uma jornada que foi crescendo durante 2 anos, que é fruto já de uma série de viagens, uma série de observações que a gente vem fazendo repetidamente. Alguns prédios que nós vimos aqui eu já visitei 3 vezes, com grupos diferentes. E esses grupos estão difundindo esse conhecimento já faz algum tempo. Esse trabalho coletivo é fundamental. O Núcleo da Madeira existe, não por acaso, não é para ganhar palminha na internet, não é para ganhar joinha no Instagram, mas é para trocar ideias. Ele existe para criar engajamento, criar vontade, criar um prazer pela mudança, não só pela necessidade da mudança, porque a mudança é obrigatória. Vocês viram esse comentário de todos os que participaram dessas mesas até agora, e nós ouvimos esse comentário em detalhes durante os 4 dias de intenso trabalho que nós fizemos no nosso, vamos chamar de retiro, num lugar muito bacana, agradável, numa fazenda orgânica, que nos deu todo o suporte necessário para não só relaxar, mas para tirar conclusões do próprio ambiente. O ambiente nos ensinou muito durante essa jornada. Então, em primeiro lugar, eu queria agradecer aos nossos convidados que toparam fazer parte desse time, dessa discussão. Não é um trabalho que acabou agora, ele vai continuar agora na redação de um documento que vai ser apresentado na COP no final do ano, que contém instruções, recomendações globais, de caráter global, não é só para a floresta amazônica ou só para as florestas individuais de cada um dos países, mas é para desenvolver uma troca real e justa, sobretudo justa, de conhecimento e tecnologia entre os países. A incrível generosidade com que essas pessoas que foram convidadas contaram detalhes e profundidades dos seus trabalhos, dos seus erros e acertos, porque isso faz parte. Enquanto a gente trabalha pensando na perfeição, Takaharu falou várias vezes da imperfeição. O Christophe falou também da importância da imperfeição. Quando a gente trabalha com certezas, a gente fecha as portas para as outras possibilidades. A gente acha que começa um projeto com razão. Na verdade, a gente começa um projeto com preconceito, na medida em que a gente não vai aceitar nenhuma mudança ao longo desse projeto. Principalmente quando a gente está mais preocupado em se projetar do que, de fato, entender o que o cliente precisa, o que o homem do outro lado, a mulher do outro lado, realmente necessitam. Então, o nosso trabalho não é um trabalho de autopromoção, o nosso trabalho é um trabalho de uma extrema complexidade urbana, que tem um nome muito bonito, chama-se civilização, civilidade. E esse respeito com o outro, essa diferença que a Kazu chamou de amor, e que cada um de nós usa palavras diferentes, mas vocês viram isso acontecendo em todos os projetos, vem de uma capacidade especial, é a nossa capacidade de ouvir, de fato, e não de achar que ouviu, tá, entendi, eu vou em frente. Então, no momento em que a gente tem essa abertura para ouvir, essa abertura para trabalhar junto, a coisa pode adquirir um caráter diferente e adquirir a urgência que o Eric acabou de falar. Não dá mais para esperar, não dá para fazer business as usual. Nós não temos mais espaço para isso. Todos nós temos a nossa responsabilidade em procurar coisas, procurar alternativas, procurar respostas, mas não para um ganho pessoal, mas para um ganho coletivo. Nós estamos trabalhando por um modelo de trabalho coletivo, que é um modelo de trabalho pré-competitivo, aquele em que a gente consegue o engajamento da indústria, aquele que a gente consegue o engajamento das pessoas, aquele que a gente consegue o engajamento dos governos, e pode desenvolver ideias, desenvolver conceitos novos, combinar coisas que nunca foram combinadas, como o Christophe falou, da comida. Ele acha que a comida avançou muito mais do que qualquer outra forma de expressão, porque ela é uma expressão coletiva. Tem alguém que planta, alguém que cozinha, um monte de gente que trabalha numa cozinha, ela é uma expressão. E se a gente olhar para a comida oriental, para a comida japonesa, a gente vai ver que cada arranjo de um sashimi, de um prato, etc., existe ali um amor, um respeito ao próximo, que está desenhado num prato, que foi elegantemente feito como forma de agradecimento, porque é uma troca real. Ele pagou por um prato e eu estou devolvendo com um plus, com um agradecimento, com uma visão artística do trabalho. Isso, sim, é o componente pessoal que a gente pode agregar num projeto de arquitetura. Esse é o nosso plus, e não o nosso ego sobre o projeto para ganhar likes no final da linha. Não é essa a nossa visão, pelo menos não a visão do núcleo nesse momento. Então, o que eu peço de todos é esse engajamento total no desenvolvimento, na pesquisa, na busca por soluções. Essa solução não vem junta. Então, nesse momento pré-competitivo, essa informação vem a público. Todo mundo se beneficia disso. Num segundo momento, as empresas têm as suas metas competitivas e elas são justas. Não há nada de errado com isso. Mas, quem sabe, se a gente fizer uma grande mudança comportamental, uma mudança de padrões, uma mudança real, isso tenha consequências em toda a nossa forma de produção, na nossa economia, no nosso modelo, hoje, que é um modelo selvagem de produção, de vida, de competição diária e de um estresse que derruba todo mundo. Então, eu queria que vocês agradecessem o esforço comum dessas pessoas que vieram, das pessoas que participaram do Núcleo da Madeira ativamente, de todos os voluntários que participaram desse evento da FAAP, agradecessem ao suporte que nós estamos tendo da FAAP, do IPT e de outros centros de difusão e pesquisa, porque essa é a nossa alma mater, é daqui que nós viemos e é aqui que a gente tem como difundir a informação. Eu vou abrir para perguntas, antes da gente terminar. Se vocês tiverem perguntas importantes para fazer, que não falem de vocês, que falem de perguntas reais, aquelas em que a gente realmente tem vontade de saber a informação que está do outro lado, e eu tenho certeza que qualquer um daqui, desse grupo, vai poder responder. Alguém gostaria de fazer perguntas? Ou dirigidas a algum deles? Marcos, Dominique, querem vir aqui? Deixa mais um aqui. Alguém tem perguntas? Nós vamos aqui, depois, terminando isso, a gente vai se encontrar aqui fora, vai poder conversar à vontade, trocar impressões. Você tem pergunta, é isso? É uma pergunta para os 4? Então, vamos resumir a sua pergunta. Diga.
Basicamente, a ideia que acontece, tanto na arquitetura da felicidade do senhor da câmera do arquitetura, e a ideia da arquitetura fugar juntos, eles vêm com uma ideia de...
Voltando, né? Somando ambas as ideias de arquitetura, tanto a arquitetura da felicidade quanto a arquitetura fugar, ambas parecem ter um ponto de coesão, que é um enfrentamento à tristeza hoje na nossa sociedade, né? Enquanto que da felicidade busca nutrir uma sensação de bem-estar e acolhimento, enquanto que da ideia da arquitetura fugar de simplicidade e de sustentabilidade, como que vocês enxergam o avanço disso para combater essa situação dentro da nossa sociedade e avançar na forma de compreender o que é um lar hoje dentro da arquitetura, né? Então, além de um espaço, somente um teto para se morar, mas um ponto de cura espiritual, um ponto de relacionamentos, né? De encontros.
Takahara-san.
I think your question is what is home, not the structure, okay? And I think home is a place somebody is waiting for you. House is different from home, okay? So you have to make a society or family waiting for you. It's not necessarily related as your blood, but to make that kind of place, you make some kind of intimate place. People can have happiness. Do you understand? Am I answering your question? Thank you. House is different from home. Thank you.
Kazu quer falar um pouco? Não.
I just come. I have a proposition.
Right.
I propose that we all